Correlation is a big word, but it has a simple meaning. In essence, correlation measures the relationship between two variables. It tells us how two things are related. Are they connected in some way? Do they move together, or do they move in opposite directions? Understanding this can reveal patterns in data. For example, think about height and weight. These two variables often show a relationship. Taller people often weigh more than shorter people. This is a common observation. We say height and weight are correlated. This means they have a tendency to vary together. They tend to go up and down together. When one increases, the other often does too. However, correlation doesn't tell us everything. It has its limitations. It doesn't mean one thing causes the other. Correlation is not causation, but it gives us a clue. It can point us in the right direction for further investigation. It helps us see if there's a connection. Identifying correlations can be the first step in understanding complex relationships. Correlation is a powerful tool. It is widely used in fields like science, economics, and social studies. It helps us understand the world around us. By analyzing correlations, we can gain insights into various phenomena, and it can help us make better decisions. Whether in business, education, or daily life, understanding correlations can guide our choices. Let's look at some examples. Imagine you own an ice cream shop. You sell more ice cream when it's hot outside. This is positive correlation. As temperature goes up, so do your ice cream sales. Now imagine you sell umbrellas. You sell more umbrellas when it rains. When the sun is out, you sell fewer umbrellas. This is negative correlation. As sunshine goes up, your umbrella sales go down. These examples help us see how correlation works in real life. It's about spotting patterns and relationships between things. We've seen how correlation tells us if two things are related. Regression analysis takes us a step further. It helps us predict one thing based on another. Let's go back to the ice cream example. If we know the temperature, can we predict how much ice cream we'll sell? Regression analysis can help us answer this question. It does this by finding the best line through our data points. This line is our regression line. It shows us the relationship between temperature and ice cream sales. Regression analysis is a powerful tool for making predictions. It helps us use our understanding of relationships to plan for the future. Section 4. Calculating correlation and regression. In this section, we will delve into the concepts of correlation and regression, two fundamental tools in statistics that help us understand relationships between variables. To calculate correlation, we use something called the correlation coefficient, or R. This coefficient quantifies the degree to which two variables are related. It's a number between -1 and +1. The closer the value is to either extreme, the stronger the relationship. A value of +1 means a perfect positive correlation, indicating that as one variable increases, the other also increases proportionally. A value of -1 means a perfect negative correlation, where one variable increases as the other decreases. And a value of 0 means no correlation at all, suggesting that the variables do not have any linear relationship. To calculate regression, we need two formulas, one for the slope of the line and one for the y-intercept. These formulas help us create a line that best fits our data points. The slope tells us how steep the line is, indicating the rate of change between the variables, while the y-intercept tells us where the line crosses the y-axis, representing the value of the dependent variable when the independent variable is 0. These formulas might look a bit scary, but they're just tools. They simplify the process of finding relationships in data. They help us find the best line to represent our data, making it easier to predict future values and understand trends. Remember, we don't need to memorize these formulas. Understanding the concepts is more important. We can use calculators and software to do the heavy lifting for us, allowing us to focus on interpreting the results and making informed decisions based on our analysis. Section 5. A step-by-step calculation example. Let's say we have data on hours studied and exam scores. This data can help us understand the relationship between the time spent studying and the performance in exams. Hours studied exam score, 273, 84, 95, 95. We can use these steps to calculate the correlation coefficient, which measures the strength and direction of the linear relationship between two variables. First, calculate the mean of both the hours studied and exam scores. The mean is the average value, which gives us a central point for our data. Second, calculate the difference between each data point and its respective mean. This step helps us understand how each data point deviates from the average. Third, multiply the differences for each pair of data points. Fourth, sum these products. This step combines the deviations to give us a single value that represents the relationship. And finally, divide the sum by the product of the standard deviations of both variables. The standard deviation measures the amount of variation or dispersion in a set of values. This will give us the correlation coefficient, which tells us the strength of the linear relationship between our studied and exam scores. A higher coefficient indicates a stronger relationship. We can follow a similar process to calculate the regression equation, which will allow us to predict exam scores based on hours studied. This equation can be a powerful tool for making informed decisions. Section 6. Practical applications of correlation and regression. Correlation and regression are used in many fields. Businesses use them to understand customer behavior. Doctors use them to study the effectiveness of treatments. Scientists use them to analyze data and make new discoveries. For example, a company might use regression analysis to predict future sales based on advertising spending. Or a doctor might use correlation to study the relationship between diet and heart disease. These techniques help us make sense of complex data and use it to make informed decisions. Section 7. The importance of correlation and regression in decision-making. In today's data-driven world, understanding correlation and regression is more important than ever. These tools help us identify relationships, see how different factors are connected, make predictions, and use past data to anticipate future trends. They also help us make better decisions by basing our choices on evidence and analysis. By understanding these concepts, we can become more informed consumers, citizens, and professionals. We can use data to our advantage and make smarter decisions in all areas of life.